Today in Math 30-1, we're going to look at Chapter 7, Exponential Functions. Today's first topic, 7.1, are the characteristics of exponential functions. Y equals c to the power of x is the form of an exponential function. If the c value in that equation is less than 1 but greater than 0, we're going to have a decreasing exponential function. That's the first graph. If c is greater than 1, then we're going to have an increasing exponential function, and that's the second graph. If we look at the domain, we're going to notice that x could go from negative infinity all the way to positive infinity for an exponential function, so the domain is x equals r. The range, you'll notice that the range is y is going to go all the way down to 0, but never cross it or never go past it. So that means that y has to be greater than 0, but it's never going to cross, so y is not going to be equal to 0. When we look at the number of x-intercepts, there aren't any, so it's 0. The number of y-intercepts is always going to be 1. In example 1, it says to create a table of values and then graph y equals 4 to the power of x. For part B, y is equal to 1/2 to the power of x. We're going to come back later and fill those in. Here we have example 2. To write the exponential function given its graph. So when we look at this graph, we see points at -2, 16, -1, 4, and 0, 1. Notice that the x values go up by ones, but the y values go from 16 to 4 to 1. 16 divided by 4 is 4, or times by a quarter. So my multiplier, and that's what we're always looking at, the multiplier would be 1/4 to go from 16 to 4, and 4 times a quarter would give me 1. Therefore, that's my c value. The c value is the multiplier in my equation. Now we're going to verify that. We're going to try the point -2, 16 and see if it works in what we believe is the equation. Y equals 1/4 to the power of x. So we're going to say 16 is equal to 1/4 to the power of -2. 16 is equal to 4 over 1 to the power of +2, and 16 is equal to 16. So it does work. The graph is y equals 1/4 x to the power of x. Let's finish off our graphs over on example 1. Notice that if x is to the -2, 4 to the power of -2 is 1 over 16. To the power of -1 is 1 over 4. 0 is 1. And if you plot those points, you're going to get that graph. And if you plot all the points in our second graph, you're going to get an increasing, this one's a decreasing curve. Notice in the first one, y equals 4 to the power of x, we have the c value being 4, increasing. In the second one, c is 1/2. It's between 0 and 1, and it's decreasing. Okay, here we are in example 3. Exponential functions in the form of y equals c to the power of x, where c is greater than 1, can be used to model exponential growth. Exponential functions with 0 less than x less than c is less than 1 can be used to model exponential decay. Here we have an application of exponential functions. We have the radioactive sample of uranium-225. It has a half-life of 15 days. That means the mass in grams remaining over time, t, in 15-day intervals can be modeled using the exponential graph shown. What is the initial mass of Ra-225 in this sample? And what value does the mass approach as time passes? Well, here's our answers. First of all, the initial mass is 1 gram. That's the y-intercept. And it seems to approach 0 as we go along. B, what are the domain and range of this function? Well, the domain x values tell me that x has to be greater than or equal to 0. And the range, y, is going to be anywhere between greater than 0 but less than or equal to 1. And an exponential decay model, well, that would be y equals 1/2 to the power of x, or m of t is 1/2 to the power of t. And lastly, estimate how many days it would take for radium-225 to decay to 1/30th of its original mass. Okay, well, understand, first of all, 1/30th of 1 gram is 0.03 grams. And since it says to estimate, all we have to do really is look at the graph and see where that occurs. So if you drew a line across from 0.03, you're going to see it's going to intercept at about 5. So that's 5 units, or 5 15-day intervals, which means it's going to be about 75 days. So, in summary, an exponential function of the form y equals c to the power of x, c greater than 0 is increasing for c greater than 1, and it's going to be decreasing for c between 0 and 1. It's going to be neither increasing or decreasing if c is equal to 1. It has the domain of x can be any real number, has the range of y being greater than 0 but not equal to 0. It has a y-intercept of 1, and it has no x-intercept. And it looks like it has a horizontal asymptote at y equals 0. There's our two examples, y equals 2 to the power of x, and y equals 1/2 x. Your assignment is to do page 342, numbers 1 to 8 for homework for Monday, and keeping in mind 322, numbers 1 to 21 is due for Friday, tomorrow, and your Chapter 6 exam is on Friday. Take care.